to ShiftWatch. I'm your host, Starbuck. In this episode, the current solar storms we've been seeing and their effect on our planet seem to be causing a greater awareness of this phenomenon, and rightfully so. Everything sentient formed is being affected. Just about this time last year, during some elevated Earth-affected solar activity, I turned to Dave Wallace to help explain the KP Index that I kept hearing about. This clip takes us back to that discussion just before the Summer Solstice last year. So in case you missed it, here's where you can find it. Next, the 1859 Carrington event was the most intense geomagnetic storm in recorded history, peaking on September 1st and 2nd. This reminder of what happened to the planet hopefully will serve as a wake-up call about what this cosmic process is playing out. Then, now that you have a comprehension of the Carrington event in your field, here are some of the latest seismic conditions that will imply that there's signs of this imminent pole shift happening soon. An earthquake researcher warns of mega tsunami hitting the west coast of the US with much wider global effects. See it as evidence of the energetic planetary changes that are taking place. And finally, in keeping with this episode's theme, here are some other associated seismic events reported in the past week: underwater volcanic activity.
Not all electromagnetic forces are bad. And if you go on to some of these cuckoo crazy YouTube sites about electromagnetism and the impact and the planetary electromagnetic forces weak and all these other things, it becomes a scaremongering fright show for people who are pseudoscientists. So when we look at these sites about solar activity and planetary alignments, and we hear people going, oh, the electromagnetosphere is really weak, and that causes all sorts of fibrillations in the heart, and it interferes with pacemaker technology and blah, blah, blah. Of course it does. Yeah. And I really want people like Ben Davidson and all the other people talking about the situation with the sun to look at the positive aspects of existence, the positive aspects of being able to observe these phenomena, to feel them and to not be afraid of them, because it's a beautiful part of reality. I believe very sincerely that this is an opportunity for all human beings to think about why we're here. And Lowell and I touched on in the green room the purpose of our existence and what we've come to in our existence. But I feel very personally, and I feel very deeply that each one of us is a participant in a lesson that many species, many people from other planets, all the animals, all the trees, all the rocks, the divine creator, whatever the divine creator is, because as a theoretician, I believe that time, light, gravity, and sound all arrived at the same time, because one couldn't exist without the other. From the nonstop, 6, 7, 8 month onslaught we've had from our sun during this part of the grand solar maximum, as soon as the sun went into the halfway point, and then it's now just sort of sloped over that a little bit. It's just been crazy. The X-class flares and the negatively charged ion streams and the huge waves of kinetic energized particles. Because remember, kinetic energy, it's just amazing. It exists both in light and in quantum physics and here on life. You crack your fucking baseball bat against a baseball, and that baseball is going to get you a home run because of kinetic energy. We're full of kinetic energy, human beings, because we're made of billions of particles of light. So one of the things that I did want to touch on just in science is that we hear a lot about the KP Index. All right. And this is really, Ben really needs to put a permanent reference somewhere in his site. And I've asked him to on his homepage many times over 12 years, and he's ignored it. But the KP index is one of the things that Ben shows people. And he's explained it in the past. And you have to go, but who wants to dig through 150,000, videos? So KP index, and this is, I have a website for everybody. So if you get your pen out right now, write down spaceweather.gfz, which is George Frank Zebra, GFZ dash hyphen Potsdam, all lowercase because it's Potsdam, Potsdam, and then it's .de because it's going to the German University Global Net. So if you look up spaceweather.gfz-potsdam.de, it's a registry of all the universities and all the global astronomical agencies on the planet. When they can register a magnetometer reading of a fluctuation of energized particles that strike the Earth, then they collate that data 24 hours a day with supercomputers now, and they all connect to each other. That way, NASA and NOAA and the FCC all know what's going on. Anyway, so I wanted everyone to know what the KP index is. So the KP index is set up on a three-dimensional sort of a corner of a box, and you see these different bars. Now, so there's a couple of aspects of the KP index I'm going to describe. Each one of them has a different scalar reading, and they're looking at four different aspects of the Kensifer wave to collate a global effect. So if you get all of the planetary astronomical places in Asia, and that could be East, South, and North Asia, which would be a huge swath of the planet, they can all have a specific KP reading because they were on the other side of the planet when there was a huge plasma release from the sun. So who picked it up? Okay, South America, North America, and parts of the Caribbean maybe, or no, parts of the South Pacific Isles. So there'd have been a huge swath, maybe, beginning in Chile and terminating in southern New Zealand. And there'll be that strike zone from the sun. Remember, these are coming in strike zones like that. So boom, 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 but it's millions of energized particles, and then you get struck by these streams of energy.
On September 1st, 1859, the Earth was struck by the biggest solar storm ever recorded. This event, now known as the Carrington event, provided a stark demonstration of the power of the sun and its potential to disrupt life on Earth. It is a story of dazzling auroras, sparking telegraph lines, and a scientific mystery that continues to fascinate us today. Before 1859, the idea that the sun could directly affect events on Earth beyond providing light and warmth was barely considered. But the Carrington event changed everything. It showed that the sun could unleash enormous blasts of energy across the vastness of space, with the potential to cause havoc on our planet. The event served as a wake-up call to the scientific community. It made them realize that the Earth is not isolated in space, but is intricately connected to the sun's activity. The Carrington event became a turning point in our understanding of space weather, a field that studies the sun's influence on Earth. Today, more than 160 years after the Carrington event, its story serves as a reminder of the awesome power of the sun and the need to understand and prepare for future solar storms. Richard Carrington, a dedicated amateur astronomer in England, was engrossed in his usual routine of projecting the sun's image onto a screen and sketching its features. On that fateful September morning, he observed something extraordinary. Two brilliant points of light, far brighter than any sunspot he had ever witnessed, appeared within a large sunspot group. These bright lights were solar flares, intense bursts of energy and radiation erupting from the sun's surface. Carrington, aware that he was witnessing a phenomenon of unprecedented magnitude, meticulously recorded the event. He even interrupted his observations to fetch another witness, confirming that his eyes weren't deceiving him. Unbeknownst to Carrington, another English astronomer, Richard Hodgson, was also observing the sun that day. Hodgson, independently of Carrington, also documented the unusual solar flare activity. Both men's accounts would later become crucial in establishing the link between the solar event and the remarkable terrestrial effects that followed. Their observations made on that seemingly ordinary September day would forever be etched in the annals of astronomy. They had witnessed the most powerful solar flare ever recorded, an event that would later bear Carrington's name and become synonymous with the immense power of the sun. Just hours after Carrington and Hodgson made their observations, the Earth was bombarded by a barrage of charged particles from the sun. This solar storm, as we now know it, unleashed a spectacular light show across the globe. Auroras, shimmering curtains of light in the sky, painted the heavens with vibrant hues. Typically confined to high latitudes near the Earth's poles, the auroras during the Carrington event were visible much further south. People as far south as the Caribbean and Hawaii were treated to this celestial spectacle. Newspaper reports from the time described the auroras as so bright that one could read a newspaper by their light. These auroras weren't just a visual treat. They were a visible manifestation of the Earth's magnetic field being battered by the sun's energetic particles. The beautiful display of light was a stark reminder of the invisible forces at play in the space between the sun and our planet. The widespread visibility of the auroras during the Carrington event underscores the immense power of the solar storm. It demonstrated that the sun's influence could extend far beyond its usual reach, affecting regions of Earth that rarely experience such phenomena. The Carrington event's impact went beyond dazzling auroras. The world in 1859 was experiencing the dawn of a new technology, the telegraph. This invention, which used electrical signals to transmit messages across long distances, was about to get a shocking lesson in the power of space weather. As the solar storm hit Earth, telegraph systems worldwide went haywire. Operators reported sparks flying from their equipment, some even receiving electric shocks. Telegraph paper spontaneously caught fire and systems became unresponsive or transmitted garbled messages. The disruption to the telegraph network was widespread and long-lasting. In some cases, it took hours for systems to recover. The incident highlighted the vulnerability of the emerging electrical infrastructure to the sun's unpredictable outbursts. Imagine the chaos and confusion this caused. In an age reliant on telegraphs for communication, the Carrington event served as a stark reminder that even our most advanced technologies were susceptible to the whims of the sun. The Carrington event provided more than just a spectacle and technological disruption. It offered a crucial insight into the Earth's protective shield, its magnetic field. This invisible field acts as a barrier, deflecting most of the sun's harmful radiation and charged particles. During a solar storm, the Earth's magnetic field is compressed and distorted by the onslaught of solar particles. This interaction is what drives the auroras, as charged particles are funneled towards the poles, where they interact with the atmosphere, creating the shimmering light shows. The Carrington event, with its intense auroral displays and widespread geomagnetic disturbances, provided a unique opportunity to study the Earth's magnetic field in action. Scientists were able to observe how the field responded to the solar storm and how it ultimately protected our planet from the worst of the sun's fury. This event marked a turning point in our understanding of the Earth's magnetosphere. It highlighted the crucial role of this invisible shield in protecting life on Earth from the sun's constant barrage of charged particles. The Carrington event wasn't merely a celestial spectacle, it ignited a scientific revolution. Before 1859, the connection between solar activity and terrestrial disturbances was largely unrecognized. The Carrington event, however, provided undeniable evidence that the sun could directly impact our planet. The observations of the solar flare by Carrington and Hodgson, coupled with the subsequent auroral displays and telegraph disruptions, provided the first clear link between a solar event and its effects on Earth. This realization revolutionized our understanding of the Sun-Earth connection. The Carrington event spurred a new era of research into space weather, a field that studies the sun's influence on Earth and its technological systems. Scientists began to recognize the importance of monitoring solar activity and understanding the potential risks it posed to our increasingly technological world. This event marked the beginning of a journey to unravel the complexities of space weather and its implications for humanity. Our modern society relies heavily on a vast and interconnected network of power grids, satellites, communication systems, and GPS, all of which are vulnerable to the effects of space weather. A powerful solar storm like the Carrington event could cripple power grids, leading to widespread blackouts that could last for weeks or even months. Satellites, vital for communication, navigation, and Earth observation, could be damaged or even knocked out of commission. Communication systems, including radio, television, and internet services, could experience significant disruptions. GPS systems, used for everything from navigation to financial transactions, could become unreliable or unavailable. The Carrington event serves as a stark reminder of our vulnerability to extreme space weather events. While we have made significant strides in understanding and monitoring the sun, our technological dependence makes us more susceptible to its effects than ever before.
Earthquake researcher warns of mega tsunami hitting the West Coast. What would happen if a tsunami hundreds of feet high struck the Pacific coast? According to some earthquake researchers, this nightmare scenario is more than just a distant possibility. Experts have been studying a seismic time bomb buried deep along the Cascadia subduction zone, a fault line that runs from Northern California to British Columbia. And when it ruptures, the results could be devastating. Today, we're taking a closer look into the growing concerns about a possible mega tsunami triggered by a major earthquake. We'll explore new findings, expert warnings, and what this means for millions living along the U.S. West Coast. The Cascadia subduction zone, a ticking time bomb. The Cascadia subduction zone is a 600-mile fault line off the Pacific Northwest coast, where the Juan de Fuca plate is slowly being forced beneath the North American plate. This hidden danger has the potential to unleash a magnitude 9.0 earthquake, one that could last several minutes and trigger a tsunami within minutes. The last known rupture occurred in January 1700 and sent waves all the way to Japan. Scientists say we are overdue for another. Unlike California's San Andreas Fault, which moves horizontally, the Cascadia Fault is a megathrust fault, capable of lifting the ocean floor and displacing a massive amount of water. What makes this zone particularly dangerous is its silence. It doesn't produce many small quakes, which means pressure is quietly building. In recent years, seismologists have used ocean floor sensors, GPS data, and computer simulations to better understand what might happen if the zone ruptures. Most agree on one thing: when the next big one hits, the coastal towns of Washington, Oregon, and Northern California could face destruction on a scale few can imagine. Homes and infrastructure could be wiped out by ground shaking alone. Minutes later, a massive wave could crash ashore, giving residents very little time to escape. The mega tsunami threat. Tsunamis are not rare in the Pacific Ocean, but what scientists are warning about now is something far more severe than most people are prepared for. A mega tsunami, unlike the typical coastal flood, is triggered by a sudden dramatic shift in the seafloor, exactly the kind of movement expected from a full rupture of the Cascadia subduction zone. Researchers say waves from such an event could reach heights of 100 feet or more in some areas, traveling at speeds close to 500 miles per hour. Low-lying coastal communities could be submerged within 15 to 30 minutes. A report by the Oregon Seismic Safety Policy Advisory Commission paints a stark picture. Tens of thousands could die. Hundreds of thousands could be displaced. Key infrastructure like bridges, highways, and power lines might be lost for months. One FEMA official quoted in the New Yorker said, "Our operating assumption is that everything west of Interstate 5 will be toast." The scenario isn't speculation. It's based on real geological records and computer models. Adding to the concern is new research exploring the idea of a possible Culebra event, a rare but plausible scenario where cascading faults could combine forces and trigger an even larger quake. Some researchers, like Brent Dmitruk, warn that in rare cases, these quakes could reach magnitude 10. While this idea is controversial, it's helping experts reassess the worst-case outcomes and consider whether our current evacuation plans are realistic for the size of the disaster predicted. Warnings from the scientific community. Over the past 2 decades, concern about Cascadia has moved from the fringe to the mainstream of geological research. The work of scientists like Chris Goldfinger, a marine geologist at Oregon State University, has helped shape public understanding of the threat. Goldfinger has spent years studying core samples from the ocean floor, which show layers of disturbed sediment, evidence of past megathrust earthquakes. His findings suggest that the full length of the fault has ruptured roughly every 300 to 500 years. Some segments rupture more frequently. Goldfinger's research reveals at least 41 significant earthquakes in the last 10,000 years, and 19 of those were full margin events, meaning they ruptured the entire fault. The last full margin event in 1700 devastated indigenous communities in the region and sent waves across the Pacific to Japan. The takeaway from Goldfinger's work is chilling. The next event could come at any time.
As of May 11th of 2025, there are currently 49 volcanoes which are actively erupting around the planet, a total which is 3 less than were erupting last week. One of these erupting volcanoes, representing North America's tallest actively erupting volcano, can be found a mere 70 kilometers southeast of Mexico City. There, the summit of a 22-kilometer-wide gray-top Popocatépetl volcano towers to an impressive height of 5,393 meters or 17,694 feet. Popocatépetl has been near continuously erupting since 1994, largely producing volcanic and sometimes strombolian explosions. And now, here are this week's top volcano-related news stories. In Indonesia, magma apparently moved underneath a portion of a major city, heading south and then into the magma conduit of the Aya volcano. Meanwhile, in Hawaii, Kilauea produced another episode of intense lava fountaining, but this time it was its shortest so far of the year. And, in what is this week's top story, a somewhat unexpected volcanic eruption occurred offshore of southern Mexico, sending a sizable volume of fresh basaltic lava onto the ocean floor. This occurred approximately 900 kilometers south-southwest of the city of Acapulco at approximately 2,500 meters or 8,202 feet below sea level. This did not occur at a central peaked volcano, although you can see remnant volcanic cones nearby. Instead, it originated from a raised submarine volcanic ridge that marks the boundary between the Pacific Plate to the west and the Cocos Plate to the east. This marks one of the 771 segments that comprise the 65,000-kilometer-long network of mid-ocean ridges that exist around the planet. These mid-ocean ridges represent divergent tectonic plate boundaries which over time slowly spread apart, allowing for distinct segments of them to erupt via fissures and form new oceanic crust. Mid-ocean ridges are thus responsible for all of the planet's oceanic crust, which is made of basalt, erupting at an average rate worldwide of 602 meters per second. This adds up to a whopping 19 cubic kilometers of basalt lava worldwide each year. Such mid-ocean ridge eruptions are responsible for an average of 75% of all lava erupted worldwide each year, and one occurred between April 28th and April 29th this year was one such eruption near a hydrothermal vent called Tycho that is located at these coordinates. We know that this eruption occurred as multiple scientists were performing daily dives in a submersible to the Tycho hydrothermal vent, and while on April 28th there was a healthy underwater ecosystem, the following day everything was dead, the water had elevated temperatures, and fresh basaltic lava and its glow could be observed. The dive was immediately cancelled at that time, and everyone returned safely to the surface. This marks the 4th well-documented eruption of this specific ridge segment, with other eruptions occurring twice in 1991 and once in 2005. Meanwhile, in Hawaii, this week saw Kilauea produce its 20th recent episode of intense lava fountaining. Since December 23rd of 2024, Hawaii's most currently active shield volcano has been producing a fairly predictable cycle of activity which is shown on screen. The 20th such episode began on May 5th at 10:48 a.m., initially consisting of weak and occasional overflows of its 2 active craters, marking a process known as gas pistoning. This process repeated more than 30 times on May 5th, and the following day activity progressively increased. Occasional low-level and dome fountains then occurred before escalating to full fountaining at 5:28 p.m. on May 6th. Continuous lava fountains then rose to a height of 500 feet, continuing for multiple hours straight. For the first 30 minutes, an average lava fusion rate of 200 cubic meters per second was observed. However, activity eventually started to subside, and by 9:58 p.m. it had ended. This intense fountaining phase was the shortest of the 20 recent Kilauea episodes by nearly a factor of 2. And in Indonesia, an uptick in activity once again occurred at the Aya volcano, which is situated at the edge of and just south of the city of End, population 89,000. Aya consists of 3 volcanic cones, although only the southernmost has erupted in historical times. Aya has been displaying signs of unrest since October of last year, involving a magmatic intrusion which eventually failed. It appears that another such intrusion began on May 4th, but strangely, magma originated not from directly below Aya's cone, but rather from what must be a previously unknown magma chamber beneath the Meja cone. Located at 7 kilometers depth, this magma moved horizontally to enter Aya's magma conduit, rising slightly and sending large volumes of gas upwards to create a sustained white gas plume. Activity has since decreased, but with a theoretical potential for the magma supply to resume, Aya is currently at an alert level of yellow. Here is a quick list of all the world's volcanoes which are currently erupting. Additionally, here are some volcanoes showing signs of unrest which are not erupting as of the recording of this video on May 10th of 2025.